It's great to be here. For everybody on the call, thanks for joining us today. This presentation has been made about 100 times over the last 4 years to private sector clients and public clients, government officials at municipal and provincial governments across Canada. And we're really thrilled. You know, we made the presentation to the CCA, some of their boards earlier this year, and they were so kind as to invite us to share the presentation. And it's actually a 1-hour presentation. We're going to do an abridged format of it today, where we just talk about contract models. And at the end of the presentation, we'll have questions and answers. And I'll also make reference to some, additional topics that if you want more information about them, you can contact us here at Graham, or you can contact the CCA to follow up on those things. The contents of what we're going to go through is just the seminar is called Emerging Contract Models for Better Projects, and really it's about collaboration. And collaboration used to refer to early contractor involvement, but now it's just become the term of itself. So I tend to explain why the collaboration works when you get a contractor involved, and then we'll go through some early contractor involvement contract models and explain the mechanics behind them and when is a good time to use them. And then I'll mention those related topics, and we'll do some questions and answers. So the presentation should take about 32 minutes from here, and then we'll have about 10 minutes for Q&A. So just in terms of a introduction, early contractor involvement is not a contract model itself. I kind of refer to ECI as a philosophy umbrella, and underneath the umbrella are a variety of contract models for different situations which invoke one form or another of collaboration with the construction contractor. And a key message in this presentation is that it's not one size fits all for contract models. We see some in the market suggesting all projects should be done with this model, this collaboration model, but we'll explain today how to make a good choice and why it's important to get the right model for the right job. And a second key message today, and I have found that some owners aren't as sensitive to this as other owners, is that the owner's cost of using any contract model should provide a return on investment. So that if you have a $20 million project and you spend $1 million hiring facilitators and consultants and lawyers and legal people to draft up the documents and to run a procurement process, you could then go to your finance people at the end of the project and say, look, it was a $20 million job. We spent $1 million using this contract model, but it generated a return of, more than $1 million. If it's not generating a return larger than the investment that you're making to use that contract model, that delta needs to be respected. It suggests that the value creation opportunities weren't there for that type of project, and maybe you overdid it with the contract model that you used. So to illustrate the concept of early contractor involvement, I like to use this chart. On the x-axis at the bottom of the chart is project duration from start to completion, and on the left-hand side is the ability to influence the outcome of the project, which is obviously higher at the start of the job and lower once things get moving. And then on the right-hand side is the cumulative project cost. And you see the traditional S-curve that happens when the construction company mobilizes, and there's a ramp up of equipment procurement that causes the curve to go more vertical. To explain ECI, I like to add the different phases of a project, and depending what sector you're in, these phases might be different, but you can all relate that there's a feasibility phase, a pre-design phase. In the oil and gas industry, they would call that FEED, and then there's detailed design and procurement of long lead equipment, and then there's construction and startup, and we can extend those phases up onto the project and cost diagram. And then we add a contract model, and in design, bid, build, what you see there is that the owner and the designer collaborate together until the end of detailed design, and then a tender is issued, and then construction occurs, and the contractor comes in And there's two things to note here. One is that obviously the owner and the designer are working by themselves to make all the key decisions on the project. And the second thing is that the contractor comes in to build, and they're not collaborating with the owner and the designer through the execution. They're referring to the tender documents to deliver the project. And the second thing is we've highlighted here part of the graph, which is really important. All of, what the graph is showing is that the big decisions made on a project, which have the highest influence on the total cumulative cost, they're made very early in the development of the project. And the philosophy with ECI and collaborative contract models is maybe we should have, and I know a lot of you have experienced this in your work, is maybe we should have a construction contractor sitting at the table to help make some of those decisions, the type of facility, the redundancy on the facility, even the location facility, and making those big decisions early on, which have a higher influence. And as you can see in design bid build, it doesn't happen. We can add design build. And in my experience, when I was a project manager working for the owner, I always thought that design build solved this problem, because we have the in the design build contract, we have the designer and the contractor working together. But if you look at the bottom of this slide, what's missing during that design build phase is that the owner is not involved. And so here again, it's kind of similar to the design bid build situation, where you have an owner and an owner's engineer making all the big decisions about the facility, which really have the greatest influence on the final cost of the project. And yet the construction contractor is still not involved in that conversation. And then it's almost worse when it gets turned over to the design build contractor. They have a thorough specification to build from. In Canada, we kind of advance designs with the owner and owner's engineer to 30% prior to the design build RFP low price shootout competition that happens in the traditional design build in Canada. And the owner and the owner's engineer have to make those 30% drawings and that specification. And if anything's missing from those drawings or specs, we know it becomes quite expensive for the design build contractor to incorporate change. And the reason is because they have their assignment, they have their game plan, they're building this version of the project, and any change that comes in later from the owner's point of view, often you get the operations and maintenance people involved in the facility, and they say, we wanted this and we would like this. And it's very expensive, and it's a disruption to the design builder it's a disruption to their execution schedule, which of course they built up on a lowest cost basis. They don't have the float to accommodate change. And so we add a third type of contract model to this slide, and it's called early contractor involvement, where you have all three primary parties, the owner, the designer, and the contractor, collaborating as early as possible in the development of the project. So ECI enables three-party collaboration during the period of highest influence. This opportunity is missed with design bid build and design build. So those are the kind of the mechanics of why ECI works. And again, I make the point here, thinking about design build, is that the good thing is it puts the designer and the contractor on the same team, and the contractor does get involved kind of at the 30% stage. But again, the owner has less involvement or influence during the design build phase, and the contractor was not involved in the early decisions that really influenced the cost of that job. And the requirement for a design build bid package is expensive and demanding. So the design build bid package is often not complete, because you only build a new water treatment plant or a new hockey arena once a generation, and the people who collaborated on that specification package might have not thought of everything, the things that are in your blind spots that you don't know to include in the package. And then the project funds are spent on procuring this three-party. You're paying for a design competition, because often there's honoraria for the companies that don't win the job, and then a lot of money spent on procurement people and lawyers, and if you're have advisors and that sort of thing. So in early contractor involvement, we like to say that the biggest improvement is the communications. And on the left-hand side, we have procurement communications during the tender phase without early contractor involvement. And it's a little bulky, because the the contractor in the top left-hand corner, sends an email, request for information to the owner. The owner receives it and then fires back an email. And that's really clumsy because often the contractor doesn't explain why they're asking the question. And when the owner responds, they often don't respond why they're answering in the way. It would be nice if the contractor could send that question and the owner could say, why are you asking? And then the contractor says, I'm asking because of this. And the owner could say, oh, well, what if we did this? And the contractor says, I didn't know you could do that. And the owner says, yes, we can do that. And then how does that affect the risk contingency that you're carrying on that item? None of that happens in the bulky RFI process. If you use early contractor involvement on the right-hand side of this slide, procurement communications with ECI, you have the different parties sitting around the table and you actually negotiate project scope, project risk, and project price. And what's important about negotiating project risk is there's a lot that happens inside risk, which is risk identification, risk definition. Then there's the opportunity for collaborative risk mitigation. How can all three parties work together to mitigate the risk, to lower the probability that it could happen, or to somehow de-risk that item and thereby reduce the contingency that the contractor might carry in the event that that risk is realized during the job? After risk definition, you go through the options. You could work with your designer and your construction contractor to review options to mitigate the risk. And you do collaborative risk mitigation, as I mentioned, and then you can also talk about risk valuation and get into that conversation about, in early contract involvement, you usually have an open book cost estimate, and the owner gets the opportunity and the designer get the opportunity to see that risk item's costing $5 million. So in a design build competition and in a bid build competition, the owner has no way of knowing how much money did the contractor carry for a particular risk. But in an ECI format, not only do you have the opportunity to see it, you also have the opportunity to discuss it. And my point about, hey, if I did this in the owner, does that lower the contingency? And you might lower the contingency from $5 million to $1 million. And then the owner thinks about it and says, I'm actually holding the risk at the end of the day anyways. Why don't I just take that risk and not make the contractor take that risk? Because I'm going to be on the hook for it anyways as the owner. And you go through this collaborative process of negotiating scope, risk, and price. And then also in an early contractor involvement scenario, you can do early field investigation. So you can establish your geotechnical baseline for a linear project, or you can go out and get the more detailed geotech work, and you can do archaeological studies and you can do environmental studies. You can actually get some construction done in terms of early works. You can do your stakeholder management where the commitments being made by the owner's team are being made with the construction contractor sitting at the table. So they're not surprised later when they find out about a commitment that was made to a stakeholder that maybe wasn't communicated well in the packages. And then what happens in this team environment with everybody sitting around the table is that a project identity starts to form where I work for the project becomes more important to I work for Graham Construction. And it's a group of people then identifying themselves with a project, and they get into day-to-day innovation and collaborative problem solving, and magic starts to happen. That's where you de-risk and you innovate and you solve each other's problems, whether it's a construction problem or an owner problem or a design problem. You got everybody pulling on the reins to solve that problem, and us and them kind of disappears, and it becomes we are delivering this project. And so it's a really powerful team experience. So that's kind of the mechanics of ECI, and I really emphasize both the improved communications during the procurement stage and during the pre-planning phase before you mobilize to the field. And I really emphasize the opportunity to negotiate risk and talk about contingency that the contractor is carrying and how to reduce it. In this slide, it looks at a few contract models for ECI, and it's a qualitative graph. Over on the left-hand side, we have the importance of end user input into the design or development of that project, or the level of effort required by the owner or the cost incurred by the owner to invoke some of these contract models that you see on the green line. And on the bottom x-axis is kind of the expected team collaboration behaviors. You know that in a bid build situation, the contractor is merely responding to the documents and providing a price, and design build actually isn't all that different. except that that team innovates a bit to get their price down. As you go into construction management, progressive design build, the city of Edmonton uses something called CCGC, which I also refer to as design assist. And then integrated project delivery. You can see that the collaboration behaviors become proactive and they become value creation. And then you get to integrated project delivery and alliance. And in alliance, you're empowered to really do amazing things and kind of satisfy program visions and come up with new ideas to develop that asset. And so you can see where there's high collaboration during procurement and execution, where there's low collaboration. And as I mentioned at the outset here, a model's cost effort should yield a return on investment. And so when you think about, could I use integrated project delivery for my, believe it or not, there's a client using it for a concrete box to hold water, a water storage reservoir. And you think of the cost incurred, are you going to be able to generate the savings to demonstrate to your finance people that you actually yielded a positive return on the investment they made to use that model? What with the IPD advisor and the different contract documents that you had to pay to develop, and the cost of running the procurement, and then all the work that goes along with delivering an IPD. Do you really need it for a concrete box? And are you able to find the value to justify having used that model? And the other point that we like to make, actually, this slide just shows that you can use any of these contract models in frameworks. And one of Graham's points that we make to the P3 Marketing Canada, which we won't cover today, is that you can use project financing, not just for design build, but for any of these models. And we have a way, Graham has a suggested way to optimize the Canadian P3 model, which we cover in other presentations. The other point I was going to make there is select an optimal contract model. It's not one contract model for all your projects. Try to look at what we recommend is look at the risks on the project. What are the behaviors that are required to manage those risks? And then which contract model unlocks those behaviors? And so, the big box management consulting firms like to talk about value for money, which is another way to say the low bid. And the low bid is often the biggest risk taker, or the team that made a mistake and didn't unpackage the bid documents properly. And so we don't think that the low bid is the right way to deliver a project. And I digress. Now we're going to jump into kind of those contract delivery contract procurement models that were on the slide. And we're going to go through each one of them. We already talked about design build, and the mechanics, of course, are that the owner and the owner's engineer prepare that 30% design package. And then there's 3 shortlisted bidders, basically evaluated on price with pass fail technical check. And then the request for information and the commercially confidential meetings, where really, you're not allowed to discuss too much. It's still bulky, and the owner has no visibility into what contingency is being carried for risks, or how risks are being managed. And there's kind of a lack of ability to innovate, because everything's so prescribed with the specification package. The design build, the 3 bidders complete the design, and then the winning bidder constructs it, and there's an honorarium for unsuccessful bidders. And we already discussed the pros and cons. I think the pro of design build is it does maximize that commercial tension, that price competition and risk transfer for a project that can be well defined. And that's really critical. A project that can be well defined, so you can wrap it up in that 30% spec, and you can show really what you want to do in the 30% drawings, not the 30% spec, the design build spec and the 30% drawings, in a way that there's not going to be varying interpretation of the requirements, which leads to disputes as a con. And a lot of contractors in Canada are backing away from design builds, and the reason is it costs a lot of money to participate in that procurement. And you think for $50 million, a construction contractor might spend $1.5 million out of their pocket to bid that job with a 1 in 3 chance of winning it. Not only is that costly, especially if you don't win, but what are the opportunity costs for other more attractive projects that you didn't bid on? And so contractors are really selective, and design build is not as popular as it used to be. And again, we mentioned that the owner is not involved in the detailed design, and often that's when the O&M people show up with their wish lists, and the builder is often is not involved in the pre-design, which is where all the big decisions get made. So we kind of covered that off. So the sweet spot for a design build project is a well-defined project which is greenfield, and a project which is less stakeholder driven. There's less end user requirements, and so you can think of a ring road, which has been very popular in Alberta. They've had about 8 ring road projects to build these highway systems that circumnavigate Edmonton and Calgary, and they're greenfield. They're through the farmer's field. It's easy to specify the road that you want and the asphalt that you want and the 30-year performance that you want out of the project from an O&M point of view. And it's easy to put that in a document and get competitive bids on that. And then during execution, there should be very few disagreements about what was required because it's easily defined, similar to a new warehouse or new commercial retail, anything that's linear, such as I have pipelines in there, but of course, when you're going through the mountains and populated areas, maybe there is more to be said for the importance of end user input, and maybe design build isn't the best model for pipeline and transmission line. But those are the kind of things that are greenfield and well defined for design build. Construction management is the next model we want to discuss, and the way that this works is the owner has a separate contract with the designer and with the construction manager, and often the construction manager is brought in a little bit too late to really make an impact. The design has been advanced too far that the ideas that the construction manager tries to make to save money might have already passed. So do you want to go back and redesign? So try to bring your construction manager in as early as possible. And a drawback with construction management is that the construction manager is often compensated as a percentage of construction costs, which may be converted to lump sum on a guaranteed maximum price basis. I'll address that in a moment. A nice thing about construction management is that the CM will run market procurement for their subcontracts, and this provides transparency and visibility into how the price got built up. The construction manager approach is good for fast track schedule driven projects, and in Canada, Graham's advice is please avoid schedule driven projects. Try to have a cost driven project every time instead of a schedule driven project. So on the negative side of CM is that because the contractor gets paid as a percentage of project cost, obviously the higher the cost of the project goes up, the more the construction manager is getting paid. And so what you want to be careful when selecting your CM is, are they going to demonstrate the right behaviors to minimize the price, to add value and bring the cost down? Or are you hiring a CM who comes into your office and says, what do you want me to do? And any CM who says, what do you want us to do? That's a warning sign, because there's a saying sometimes that chaos is cash in a situation that's not well managed. And as the price goes up, so does the fee that the CM is taking away. And that's not in every case, but the point is, be diligent in who you hire, and try to bake an off ramp into your construction management contracts, where if you're not happy, you're gonna take the off ramp and end that contract and tender the job with the input that CM provided. And as we wrote here, it can be difficult to align all three parties. I think some people have had the CM experience of who's in charge, and sometimes groupthink takes over. But anyways, there are a lot of places where construction management makes sense, and it does provide great transparency into how the cost is built up. And with the right construction manager, you can solve a lot of problems and a lot of unknowns. So we think the sweet spot for construction management is when it is difficult for the owner to define the project scope and fast track project situations. So when I say it's difficult to define the project scope, often this is a brownfield project. There's a situation where we watched the tender unfold on a wastewater treatment plant project in Canada, where the owner knew the facility was needing some improvements. The concrete was falling apart, and there were problems in the flooded sections of the plant where they needed upgrades, but they didn't know what the what the improvements were because it's flooded, and they wouldn't know until they took the plant offline and the construction contractor standing there. This particular procurement was run as a lump sum bid build, if you can believe it, without knowing what the scope was. Whereas if you had a construction manager poised to do whatever was required when the facility is drained, the project probably would have cost less, because you can imagine all the risk contingency that a bidder would try to bake into a job for the unknowns of what they're going to find. And of course, it was unit price, which is the right way to do it, but you're still going to find unknowns and make discoveries that are going to require changes to that lump sum contract. And wouldn't it be better to drain the plant and then define the scope with the construction manager and then execute? So that's an example of a good use of a CM approach. And also CM is really useful when there's a lot of subcontracted work on a job. When you have a self-performed construction contractor, they don't want to procure to the market. They want to self-perform those scopes, and it's in their control. They're going to do it cheaper, and they're going to do it at a higher quality than bringing in subs. And so for subcontracted industries, particularly the building sector, construction management is excellent to develop that transparency into what are the costs of the subcontractors and suppliers coming into the bid, into the procurement of the construction manager. So the next one is called progressive design build, and this is something that's a little bit more popular in the States. If anybody wants to see the reference documents, I refer you to the Design Build Institute of America, which I think they recently rebranded themselves, but I don't remember what they call it. But they've been advocating for progressive design build, and the mechanics are that the owner hires the design build contractor as early as possible in the development of the project. And so you think that 30% drawings and the specification, that doesn't exist. Instead of paying for a 3-party design competition, you're hiring one design build contractor, you're developing one design, and it's often the design that the owner wanted in the first place without having to produce the specification and the 30% drawings. The scope, risk management, and open book pricing of a guaranteed maximum price are developed progressively over time as the definition comes into the job, and with true 3-party collaboration. And here, of course, just like with CM, the construction contractors paid for that design phase effort. So what's good about progressive design build is you can accomplish similar risk transfer as a design build, and you do get that cost certainty, but you have the earlier involvement of the contractor, and it's a better use of owner funds because you're avoiding that costly procurement with all of its advisors and technical advisors and people involved in the job, in the procurement. Shorter design and execution schedule. You can do a progressive design build much faster because you're eliminating that 9-month competitive design process. You're going to collaboratively design one version of the project in 3 months or in 6 months, and then all the work to procure and award a design build contract disappears, and so you'll have lower procurement costs. One of the points that isn't made on this slide with progressive design build, I guess it's on the next slide. Just on the negative side of design build, it does require kind of good staff to manage decision making. Same with construction management. If the owner's team is able to keep the construction manager or the design builder on task and even manage their own staff and the designer from scope creep, and the difference between needs and wants becomes really important, and that's a role that the owner needs to take on to adjudicate what do we really need to spend money on and what is a nice to have. And then the other thing that comes up here is the owner's comfort level with qualifications-based selection, because you're hiring your progressive design build contractor before there's something for them to bid on. And so in a different presentation, we explain, what are some of the commercial elements you can bake into the procurement, such as fee and overheads for direct costs and overheads for indirect costs. How can you get that stuff during the procurement and then bake it into the final cost estimate, and thereby create some competitive tension during your procurement, during your qualifications-based procurement, maybe 70% qualifications and 30% price. So this contract model is very well suited to projects with process performance risk transfer. We think of a water treatment plant or a wastewater treatment plant. or projects that are driven by the life cycle cost, the O&M costs of operating a facility. And here's the point I was trying to make. A progressive design build is very good when the owner knows what they want. So Graham just worked on a project with the Buffalo Pound Water Corporation in Moose Jaw, Saskatchewan. That plant supplies water to the city of Regina and the city of Moose Jaw. And the owner is very knowledgeable on what they want, because over the years they've done a lot of lab testing and piloting of different manufacturers' equipments, and they kind of knew what the plot plan should look like, or not the plot plan, the process flow diagram, which unit processes they wanted in the design. And therefore they just needed to bring in a design builder to help make it a reality. So it's good for water treatment, complex transportation, hospitals, sports complexes, and particularly well suited for brownfield projects. I'm just doing a time check and realizing I need to speed up a little bit. Design assist is a similar situation to progressive design build, but the owner already has their designer that they want for the facility. They've already been working with that designer. Now you just add a construction contractor. So there is a separate contractor with both the owner and the designer, and the contractor may bid on a partly completed design, and the contractor again is paid for the design build effort. And so the risk transfer here can be similar to progressive design build, and you do have true three-party collaboration, but the designer and the builder are not on the same team, and so the owner might need to referee. And the way that you do that is to have some real sharp clauses in the contracts for the designer and the builder. And an example is that the ownership of the project schedule should go with the construction contractor. The ownership of the cost estimate should be the construction contractor. So often we get the design team having their own schedule and the contractor having their own schedule, but an owner can solve some of that disagreement by assigning who's doing what, and strong owner staff to avoid that cost and schedule creep. And so a good example of this project, well-defined project with complex delivery aspects. Again, water treatment, transportation, sportsplex, complex building renovations. In the city of Calgary, they procured a construction contractor for the construction of a diverging diamond traffic intersection, the first one in Canada, which helps left turn movements in both directions. They knew, ISL Engineering and the city of Calgary knew what they wanted the final project to look like, but they didn't know, they needed a contractor's help with phasing and temporary works. How can we get this done as fast as possible and minimize the disruptions to the traveling public? So what they did, the city of Calgary tendered the project at 70% completed, and they took bids. And then after the bid phase, they just had a simple clause in their standard bid build contract that said there's going to be a design optimization phase where we work on optimizing the design, the staging, understanding what the temporary works are going to look like. And they worked their way up to 100% design. And as changes were made to the design that impacted the schedule or cost of the contractor, that was just dealt with simple change orders. So a very innovative contract model that we call Design Assist by the city of Calgary at very low cost to them, to slightly tweak what normally happens in a bid build situation. And we can also use progressive design build to slightly tweak what we're used to doing in design build. The city of Edmonton refers to the design assist model that I just described as construction consultant, general contractor, and they're very pleased to share their experience with their model. And you can find conference presentations online from the city of Edmonton about that. And similarly, the city of Calgary is happy to speak about their design assist. In the United States, you might hear it as construction management, general contractor. I often get asked, is construction management the form of design assist? And yes, it is, absolutely. So now just the last two contract models. IPD is where you have an integrated team that collaborates on the design towards a target price. So the owner says, we have $70 million for this job. What can we get? And the contractor and the designer and maybe the key sub trades, electrical, mechanical, or a key equipment provider at a wastewater treatment plant or something like that, they come in, and what happens is that all project players that I just mentioned sign on to a poly-partner agreement, which sets a risk and reward. The contractor might take 40% risk reward, the owner might take 10%, the designer might take 8%, and then a key OEM might take 20%, or a key sub-trade. And each company has their profit at risk on any overruns on the job, but they're kept whole on their direct costs, even their indirect costs and their overheads. But as you eat into that, as you have an overrun on the job, you eat into the profit which each company was going to book. And the unfortunate part is that if it goes above that and all the profit is eaten, then the owner carries the overruns beyond the profit loss. And then savings below the target price are shared according to that risk reward, according to those percentages. The erosion of the or the consumption of the profit is also done according to those risk reward percentages. So it's a very collaborative model. You're designing to cost, and so it's nice to work towards a budget, but you can also do that in progressive design build and in construction management. You can also do that. But the key about this model is it enables significant input for end users and subtrades and OEMs. And so you can really bring in your end clients, maybe public folks who are going to use a hockey arena, or judges that are going to use a courthouse, or doctors and nurses that are going to use a hospital. And you can really start to understand what they need in the design to maximize the value of that facility. But you can imagine that costs a lot of money. And in order to demonstrate a return on investment, that team has to generate a significant amount of cost savings. And what I see some owners doing is kind of jumping to this model without considering the additional cost that they're taking on to use that model. And I used the example of the water storage reservoir earlier. So it is easy for this model to result in scope cost creep, and the difference between needs and wants really needs to be managed. And more owner resources. Usually your O&M people are involved in this model from the beginning. So projects, the sweet spot for this model is projects which require end user input or OEM input, and it's particularly useful in those buildings and public facilities that really rely on subcontracted construction sectors to build that collaborative team. And then the last model I wanted to discuss, which is alliances, and I don't have a lot of time to go into this. Alliance is basically used where the owner, or let me rephrase, the risk profile of the job is so complex or so undefinable, you can't even define the risks on the job, that the owner turns to an alliance to say, I need a contractor, I need a designer, maybe they come as a design builder, or maybe they come separately, but let's create an alliance where the shared risk reward is predefined by the owner. Again, the contractor loss is capped at profit fee only, and it's kind of a blame-free project culture, which does take a long time to shift to. They use alliances in New Zealand, and I was talking to them there. They have 20 years of lessons learned on alliances where projects did cost too much, and they needed still to get, and they said they still have a ways to go to get good at it. And the example that we have in Canada is Union Station in Toronto. The risk profile was so high that you might not find a bidder to come in to do that, to bid on that as a design build, or to bid on it as a lump sum job. And so the reason Metrolinx chose the alliance was just to say, we need a good contractor and a good designer that we can trust, and let's define scope, risk, manage risk collaboratively, and negotiate the price. And so it's really, you can read that slide, but the sweet spot is projects with risk profile so high or unknown that contractors are reluctant to bid. And we do see it used on larger programs over time. In the oil sands in Western Canada, they have engineering alliances that go in and work with a company like Suncor to kind of work on a program of works. And what happens is design and construction execution costs will fall over time as people learn to work together and learn about the owner preferences. So that's the end of the presentation. Here are some related topics that we like to talk about in a longer presentation that you'll see us on the conference circuit. And Graham is also willing to visit your office and make this presentation to you folks in your team. And you can also reach out to the CCA to discuss these topics. But how to maintain competitive tension in QBS. And the other thing that we now talk about is how do you prevent corruption in a quality-based selection environment. So Graham does have some guidance for owners on those topics. And then what are best practices for procurement and managing an ECI contract? We talked about optimizing Canada's P3 model. Follow up with me or CCA for any questions.